Alright guys, so as I said, and I'm just gonna record it with the number 5, 6, 7. Okay, so it's the second part. So let's start with the number 5. Okay, now if you look at the graph, we have 2 vertical asymptotes and 1 horizontal asymptote. And I do have hole right here. This is very important. I noticed we have hole at, it's about negative 1.5 because we can verify it. It's between negative 1 and negative 2 y coordinate. So let's approximate 0, negative 1.5 for now. Okay. As you already saw in previous example, the exact y value will be just approximated and then it's gonna work, right? Okay, so then let's fill the table first. So we can fill with the hole at 0, negative 1.5. The vertical asymptote, first one that I can see is where x equals negative 2 and x equals positive 1. Then the horizontal asymptote is at y equals positive 1. I don't have any slant asymptote, but I do have 2 x-intercept here. One is observed at negative 3, 0. The other one is at negative 1, 0. And no more x-intercept. And so then this was hole, but also it's gonna serve as y-intercept as well. So technically it's break, open circle at the position, but we can pretend your graph was supposed to pass through at 0, negative 1.5. So it's technically at hole, but we can still assume the position as the same position of the hole. Get it? Okay. So then let's do one by one. So since I have 2 vertical asymptote, then I can start with 2 parentheses from vertical asymptote here. When x is negative 2, and it's gonna make the factor x plus 2. And when I have vertical asymptote at 1, positive 1, and then the factor that was creating this was supposed to be x minus 1. Then now I have to also serve the fact that I have hole at 1. So x coordinate of the hole is 0. Then I should have had the common factor top and bottom, which is x plus 0 on the bottom, x plus 0 on the top, so that I was supposed to cancel them, so that I was supposed to have hole at 0, somewhere. See that? Okay. Then now, I know for sure having horizontal asymptote at y equals positive 1, then I have to set the numerator and denominator with same degree. So then now this is 1, 2, 3, degree of 3. And then now, because of the hole, I have one exactly same degree covered. But then since I have 2 more, and I need to have at least 2 more degree to set up, then also I can tell by looking at the value of the horizontal asymptote that the leading coefficient from each side could be 1 over 1, so that it was supposed to make 1 here. So then, since I have to have 2 more degrees to match the degree of the bottom, then I will need quadratic, the degree of 2 expression in here. So now I can make ax squared plus bx plus c, but we already determined to have the leading coefficient 1 over 1, so I don't have to worry about additional a in front of x squared. So now I'm just gonna write x squared plus, I don't know b, I don't know c yet. So this could be the format that we can start with. But let's recap how we got each factors from the key features here. These 2 vertical asymptotes made these 2 factors down there. Then the x coordinate of the hole was making these 2 common factor top and bottom. Then now, horizontal asymptote was telling us that degree of numerator and degree of denominator should be same. So we were finding degree of 2, the quadratic expression besides this common factor on numerator side. Then it's being 1 that it makes leading coefficient top and bottom 1 over 1. So I don't have to worry about the unknown a in front of x squared, right? Okay, then now I can use y-intercept to find the c. How do I find it? You input 0 wherever you see x's, and it's gonna match negative 1.5 later. So then let's use whole structure that we just built. Then f of input then it's all 0, 0, 0. What I have left is c. Then 0 plus 0 is 0. 0 plus 2 is 2 times 0 minus 1 is negative 1. It was supposed to be negative 1.5. Then this means c over negative 2 is negative 1.5 over 1. And now cross multiply. C times 1 is c. Negative 2 times negative 1.5 will be negative, negative, positive. Twice of 1.5 is 3. Then now I can rewrite this structure with the fact c turned out to be 3. So now I don't have to write explicitly 1 there. I don't have to write x plus 0 because this one is simply what? Just x. So it looks like this, x times x squared plus bx. Now I have to write 3 instead of c over 1 times x plus 0 is just x, and it was supposed to be x plus 2 and x minus 1. Then now still I'm responsible to find b. Then either one of these x-intercept will be plugged in so that I can figure out b, right? So then let's use this. So then if I input f of -1, and it's gonna be -1 times -1 squared is 1, b times -1 is -b, and plus 3 over -1 times -1 plus 2 is 1 times -1 going in here, -1 is -2. And then that was supposed to be equal to what? 0. So then this is -1 times 4 minus. So then it's -4 plus b over -1 times 1 is -1. -1 times -2 is 0. And it's over 1, cross multiply again. Then -b plus b is 0. Then b must be 4. B must be 4. Now, we rewrite the final answer, right? So then this is x times x squared. What was b? 4. So it's going to be plus 4x plus 3 over x times x plus 2 and x minus 1. That's perfectly fine form for us to provide. So this is the answer. Okay. Let's move on to number 6. All right. Now I have slant straight line again. So this one simply looks like the linear function, but not, because I verified the hole there. This is hole at x coordinate 2, so it's 2, 4. It's very important. Okay, then now let's fill out the key features first. So then hole, where is the hole? 2, 4. So hole, one hole at 2, 4. Do I have vertical asymptote? No. Horizontal asymptote? No. Slant asymptote, technically not really asymptote, but we already saw this earlier. Then it was unofficially there with y equals mx plus b form. So then y-intercept positive 2, and it goes to the right 1 up, 1 to the right 1 up, or to the right 2 up, or 3 to the right 3 up, and so on. So it makes the slope 1, and then y-intercept, so it's x plus 2. Okay, then let's keep filling this table first. X-intercept where? Right there. So it's obviously -2, 0. Do I have y-intercept? Yeah, we already mentioned it here. So it's 0, 2. Good. Then, now, let's see all the key features in a general way. So, let's take a look at hole. I have hole at where? 2, 4. So, we focus on the x coordinate of the hole. It's at 2, positive 2. So, that means I have to have common factor that must have been cancelled top and bottom. So now I can start my first structure with common factor top and bottom based on x coordinate of the hole positive 2. So I know for sure I have the common factor x minus 2, x minus 2 top and bottom. So it could have been canceled. Then it gave us the whole at positive 2. No vertical asymptote, so no more factor on the bottom. Horizontal asymptote, no, none there. But we do have officially asymptote, it has 1x plus 2. 1x plus 2. I have to make, for slant asymptote, I have to make the degree one larger than denominator, one larger than denominator. So the has degree 1. So then I have to make the degree of numerator is 2, but this one factor will have degree 1 there. So I need what? One more factor so that x times x will make x squared, which is degree 2 on top, right? Then since the slope of this equation is, I don't really have to worry about specific ratio of coefficient from each side. So it's 1 over 1. Then I don't have to worry about anything in front of the x. So all I have to put one more factor with x, but I need to figure out what value with the unknown factor there. So I will put unknown a there. So we are responsible to find this value. Then we covered everything. So then let's recap how we came up with these factors around here. Now, these two factors, x minus 2 over x minus 2, was from where? The wholes. But why specifically x minus 2? Because the x coordinate of the whole is a positive 2. Then the factor that we were canceling before was supposed to be x minus 2 inside of the parentheses. So we started building this one there. Then no vertical asymptote, so I don't have to have additional factor there. So this x minus 2 on the denominator is only factor. Then no horizontal slant asymptote. Then we know for sure the case that gets us slant asymptote is when the degree on numerator is 1 larger than the degree of the denominator. So then degree of denominator is 1. Then I have to make the degree of numerator as 1 more. It's 2. So the only way for us to this was because that we have slant asymptote, and then since the slope was 1 and I can only imagine the leading coefficient of each side was 1 over 1, so that it was supposed to be 1 when you perform the long division there. Yeah? Okay. So then let's erase this one for space calculation, and then just redraw like this. Okay. So then with this, I can utilize what? Yes, y-intercept, so that I can figure out this a. So then let's plug it in. So f of what? Input 0. So then 1 times 0 minus 2 is minus 2. 1 times minus 2, minus 2. And times, then 0 goes in x, so 0 plus a is a. So this is just becoming negative 2 times a over, then now this is 0, so it's 0 minus 2 is minus 2. It's supposed to be what? It's 2. So then this means negative 2a over negative 2 is 2. Then cancel, a is what? 2. Oh, is that it? Yeah. Then we just figure out what a is supposed to be, just 2. So then we're done. Then you can rewrite the factor here. So because of this space, I'm just going to write it around here. So then this is just simply x minus 2. What was a? 2. So plus 2 over, what is it? X minus 2 there. That's it. That is it. It was not bad. Okay, then the last one. All right. And this one finally looks very typical to be rational function graph, right? So now I have horizontal asymptote, vertical asymptote, and there's a one hole in y-intercept, x-intercept. Okay. Then I do have a hole. I do have a hole right here. The x coordinate of the hole is obviously 2, but it looks kind of little bit off. Let's use this hole at about 2, 1.6 around approximately, right? Then hole at around around 2, I don't know, 1.6, 1.5. It doesn't matter because you remember we only need the accurate x coordinate of it, right? So just let's approximate it for now, okay? Then do I have vertical asymptote? Yes, right there. It's x is -1. And I do have y asymptote at y equals 1. Then do I have slant asymptote? No. And then do I have x? Yes, right there. It's 1, 2, 3 to the left, so it's -3, 0. Y-intercept? Yes, it's 1, 2, 3 up on the y-axis, so it's 0, +3. Okay, then let's start from the fact that we have hole. Where is the hole? 2, something. So then this will determine the common factor that we were canceling top and bottom was x what? -2. Then let's start it by writing the common factor that we were supposed to cancel top and bottom. X what? -2. X what? -2. Top and bottom. Okay. Then, do we have vertical asymptote? Yes, right there. X is minus. So I have to add one more factor. Vertical asymptote, so it's going to be x what? +1 there. Okay. Then the fact that I do have y equals 1 as horizontal asymptote forces us to figure out it's the same degree top and bottom, and being at 1, so we have leading coefficient from top and bottom is 1 and 1. Easy. But in order to match the degree, the denominator's degree is x times x is already x squared. But this one only has one factor there. So I do have to match one more factor being x plus something. So let's put the unknown a there so that we can find what value needs to be there, right? Okay, then now the degree of the numerator is also x times x is x squared, and then they are the same degree top and bottom. And then now that serves the fact that we have horizontal asymptote there. And this 1, and then it's 1 over 1. Then this structure is good enough for us to find this unknown factor, unknown value here. Okay, so then we usually use y-intercept, right? So then f of what? Input 0, it's gonna make the output 3 here. So then 1 times 0 going there, it's -2, so it's -2 times 0 going in there, so it's 0 plus a, it's times a, we don't know yet. Then 1 times 0 minus 2, so it's -2 there. And then times 0 plus 1, it's 1. It's supposed to be equal to what? 3, so 3 over 1. So that means, oh, so I can cancel -2 first. And then it's a over 1 is 3 over 1. A is what? A is 3. Oh, then we're done. That's convenient. So as long as I know a is 3, then I know everything. So then I can rewrite the final answer because there's little space, and then I'm just going to write it down here. So f of x is supposed to be on top. I don't really have to explicitly write 1 there, so I'm just going to have x minus 2, and it's a supposed to be what? 3, so x plus 3. And then I don't have to write 1 explicitly, so it's x minus 2, and then it's what? X plus 1. So it doesn't matter if you factor, it's already factor, if you expand to have your quadratic trinomial expression on top, and then you can just do that, like expansion, or you can leave it as a whole factor form, and it doesn't matter. So, I mean, just for fun, if I expand it, it's going to be x squared, then it's going to be 3x minus 2x is plus x, and then it's -6. And then this will be x squared and minus x and minus 2. So it's the same thing, either expanded form or factor form. And that's it. So I hope you guys were able to solve this in advance, and I hope you guys all got them right. And try out additional active practice with the answer on this assignment, and good luck for the quiz this week. I promise I will make it very similar to the previous one, so you guys can do it better, and I will add a couple of more like these problems in the quiz. Okay, so bye, and I hope I see you guys during Zoom meeting this Thursday and Friday. All right, okay.